You guys able to see the screen? You guys are able to see the PDF which I've shared, guys?
Yes, sir.
Yeah. Thank you. Okay. So now we have come to the second part of the fourth cycle. The fifth cycle is going to be more like an exercise for you guys, because the fifth cycle is more than the theory content. It's about the different climates: warm, humid, hot, dry, and moderate, and composite. There are 4 climates given here. And this is about understanding what that climate characteristics are. What is the maximum temperature? What is the minimum temperature? What is the relative humidity in that particular period? And what type of strategies can be adopted for each of the climate. So if you take the book, the Manual of Tropical Housing, of these climate would be specified. I think only one climate wouldn't be there. The moderate climate alone wouldn't be there. For that, I'll source out information for you. But other than that, the warm, humid, hot, dry, and composite climate. So these would be given as units in which, if they speak about the character of the particular climate, and then what are the strategies to be adopted, and how the plannings are done. So they would have done. So I would like to split up this 4 parts into probably 4 groups, so that you guys can make an individual analysis, a group analysis, and have an understanding. You can make a small presentation which can be shared with the group for each of the other batches. So with this exchange, you'll be able to have a understanding of all the climates. So that's for the 5th unit. So with regarding to the 4th unit, so now what we look into is the cavity resistance, the exercise, online tool and the exercise. We are skipping off this part, because we don't have much time to finish off this. Let's see if at all we get extra time, then we'll finish off the
professional website. I created one for our startup using Wix. Let me show you how I did it. First, go to Wix.com. Hey, what is a nation? In this session, I'm going to teach you to turn a plan sketch to a 3D model in SketchUp.
So much yeah. So what we look into today would be cavity resistance, the effect of cavity and insulation on a thermal performance of a building, then heat flow by convection and radiation, concept of solar temperature and solar gain temperature, thermal gradient to composite wall, heat exchange process in buildings, and the final is steady state assumptions. These are not much, but these are pretty much, we would have experienced all of these things, we would have seen all of these principles used. But what would be new is that we are looking into a theoretical format of it in these units. Otherwise, I'll relate each of this to a real-time function so that you have a better understanding. So, cavities. So, cavities now, as I told you, this part of the 4th unit, what we would be studying from this unit is primarily it's about the temperature gain to a building more than the climate on the outside, how the science happens between the building skin and the temperature difference of outdoor and indoor temperature. So now this part is about insulations. Why do we need insulation? It's to prevent heat loss, unnecessary heat loss, as unnecessary heat gain into a building. And what are the other reasons why we need the insulation? We'll look into it. So cavity is nothing but a air space between 2 bodies. So cavity blocks, cavity walls, you would have heard of. One easy example you can relate to is a rat trap bond, what we would have studied in your 2nd semester. They speak about cavity between 2 surfaces. So air by itself is a very good thermal insulator. It reduces it becomes a barrier for heat transfer. But without with the on top of having empty slot of air, there are different materials in which you can use do the insulation. So that is what you'll be looking into. So the cavity, if an air space or cavity is enclosed within the body through which the heat transfer is considered, this will offer another barrier to the passage of heat. It is measured as cavity resistance, RC. This is what we are speaking of is just a empty air cavity. We are not speaking of any other material on the top part. And this is represented by RC. The building insulation here, there are various description. As I told you, what is the reason why we need to have a building insulation? So one is we looked into in a colder place, as we need to have a very cozy, warm interior. Whereas in a hot place, we want to have a comparatively cooler interior. So in this way, we need to look into two things. As we all know, with the temperature, how does a thermal difference happens? Thermal difference happens when there's a transfer of heat from the higher body to the lower body. That's a physical format in which every time it goes through. Similarly, in a colder place, for example, when we keep our interiors warm, we don't want that heat to be conducted through a wall, could be any other building material, and let out. So this way, we need to keep the place. We need to have the thermal conductivity very less, so we insulate to keep the heat inside. Whereas in a hot place, what happens? The exterior is hot and the interior is comparatively cooler. So in this way, always there's going to be a temperature difference from high to low. So now we don't want the heat from the outside to come onto the inside. So these are the primary reason which building insulation is done. But what are the furthermore reasons? This is very much apt in a hot place or a much cooler place also. When any indoor space is being kept into a much cooler, as in like in a colder place, we don't want that cold part to stay throughout for a very long period, like a month or two. What happens is it starts to get moisture, it starts to form moisture on the inside, and we start to develop molds. Molds are these fungi, so which is not a healthy sign. So this way, that is another one important reason also we need to look into. So another, beyond the thermal insulation, there are various other insulations like acoustic insulation, fire insulation, impact, that is vibrations from machineries. We can use our insulations for them also. Now, what are the various types of materials which are used in insulations are cellulose, glass wool, rock wool, polystyrene, urethane foam, vermiculite, perlite, wood fiber, plant fiber, recycled cotton, denims, plant straw, animal fiber, cement, earth or soil, or any other reflective surface. All of these can be added as a insulating material between surfaces. So all of these are done on top of the first part. We looked into cavity, and the next is we look into a material. And again, all of the most of the materials in the above list only retains a large amount of air also. These are again not solid blocks wherein the heat transfer happens very quickly, but when it contains a lot of air molecules inside, it will have a minimal heat transfer. So what is this insulation? How is the insulation evaluated as? The effectiveness of bulk insulation is commonly evaluated as R value. If at all you remember, we would have studied something in the last class of transfer of heat through transmittance. How a transmittance could be any building material, could be a glass, could be a brick, a transmittance of U value. So these are two primary components which you look into. R value is regarding to insulation or resistivity, and U value is about transmittance. So that is what is mentioned here. It is important to realize a single R value or a U value does not take into account the quality of construction or local environment factor for each building. The reason why is why the R value and U value alone is not considered into the factors of the regional climate and what is the desired temperature we require on the inside. It varies from place to place. So it's not always suggested, okay, this low U values are always fine. High R value is always fine. It varies from place to place. The significance of thermal insulation preventing building damage caused by the formation of moisture. This we spoke of. Producing a comfortable thermal environment for people living in the building. This again, yes, we know. And this third point we didn't speak of, but indirectly it is also related. Reducing unwanted heating or cooling energy input. So that is why do we need to use extra resource for us to cool a place. Normally, if at all, you guys are studying site planning, you have been studying about climate and what is the orientation to follow for a building. The reason why we look into orientation is, one is, yes, to capture wind, the air movement. The second part is a primary part wherein we try to shade or safeguard all the heat gaining sides of a building. Understanding a climate, that's one important factor. We have to understand which part of the buildings get heated up at what time. So in those sites, we try to avoid giving openings. Even if we give openings, we design an appropriate shading device to prevent any heat gain. So these are the three primary significance of thermal insulation. Now, heat flow by convection and radiation. We would have already, again, this is another repetitive part, but again, as part of the content and the syllabus, we have to go through it. In convection, heat is transferred. How are heat is transferred to convection? Heat is transferred by a bodily movement of carrying medium, usually a gas or liquid. So a perfect example is on a hot day, you leave your windows open. So any breeze or any wind coming in through the window will heat up the interiors. So that's one easier example of what convection is all about. The wind from outside is carrying the heat along with it. So how this movement of air, again, this works on base of thermal forces. Temperature difference. A hot air is always lighter, where a cooler air is heavier. So temperature difference plays an important role. The rate of movement of the carrying medium in terms of kgs, specific heat of a carrying medium. Now radiation is about heat emittance from a body. In radiation heat transfer, the rate of flow of heat depends on the temperature of emitting and the receiving surface. And certain qualities of these surfaces are emittance and absorbance. So here there's two terminology which look into. The coefficient, the absorbance is put as A and the reflectance is put as R. The sum of these two coefficients are always 1. As in with the consideration for radiation, our value is calculated, how it's looked up. Yes, A is absorbance and R is reflectance, and this sum is always 1. So what happens in a light color surface? Normally they say black is a very heat sensitive and it absorbs a lot of heat. Whereas you say about a light color, white, they say it's a very reflective color. So on these two conditions, because a light color is reflective, the R value is 1 and the absorbance value is 0. So that gives you the radiation part. Whereas in a black body, R value, the reflectance is 0, whereas the absorbance is 1. So that's how it works into, and how these surfaces work on. Solar temperature. Solar temperature is nothing but, it is about how a heat happens through, we know about the radiation and the convection and the temperature difference from the outside to inside. But there is another one factor other than the atmospheric temperature, which plays an important part in the heat transfer, is the incident radiation. Radiation, which is the sun's rays incident on which side. and how that works. See, there is a temperature difference on two sides, on outdoor and indoor. But again, beyond that temperature difference, there's another one factor which plays is the angle of the radiation of incidence. The radiation of incidence is your sun's rays hitting on it. As we spoke about radiation, there are two factors which play to it: the absorbance and the reflectivity. And how that is going to work is all about solid temperature. So how these values are calculated here is sol air is T is represented as Ts in Celsius. TO is outside air temperature. I into A, which is radiation incident, watts per meter square. Absorbance is A, which is of the material. And FO is the surface conductance. Surface conductance is nothing about, it's about surface capacity to disperse the heat or to transfer the heat. So how the value varies here. Again. Here, this would have given you a calculation of how a thermal gradient through composite wall. I'll just rotate. Okay. So this is a composite wall, what we see here. So how this thermal gradient, how the temperature passes through and gets in the value. The first on the top part is the outer and the bottom part is the inner. So what are materials applied here? It's got a plaster layer on the outside surface. It's got a wood wool. It's a insulating material, a layer of concrete, air cavity, and a brick. And here, how this temperature is broken down from 0 to 20 degrees, as in like how each of the surface is taken up. You don't need to buy out any of these content. All of these contents are purely for understanding purpose on how the temperature plays a different role and in accordance to the transmittance of each of the materials. In the earlier class, I would have displayed a chart which says of the transmittance, the U value for each of the material. Heat exchange process in a to find you. Here, it is about how this thermal temperature from outside hitting on the building envelope, which is the roof and the walls, and partially taken to the floor also. And how each of the components are listed here, how the conduction happens, the solar radiation, heat exchange, and you can just have a reading of these contents. I think this is simpler than that. Again, the conduction, convection comes into the space with respect to what is mentioned here on the image. Finally, a steady state assumption is it's almost like a note to in which we read on the thermal part of the thermal difference. What steady state assumption states is it is just like a caution saying that normally when we speak about temperature on the outside and temperature on the inside, we don't constantly take one temperature. The reason, as in like we take one temperature, but in reality, if you try to analyze any place or evaluate, that doesn't happen. In nature, a temperature is not a constant factor in which you can assume a material's value. It keeps changing on various conditions. Temperature changes with respect to humidity also. But normally here, we would have considered all of these studies as we have taken in a state where the temperature is fixed and we would have taken those for understanding. But in reality, we can't do that. So that is what it says. A steady state calculation method can also be considered as a preliminary studies to lead up to understanding of more complex non-steady state heat transfer problems. So these are the contents in which we'll finish up the 4th unit. So this part is where we start off the 5th unit, in which these guys are here. Only the moderate climate alone we need to have a verification, because tropical upland climate is about hills, whereas a moderate climate is another specification. I'll get the source out here, contents for that. All of these are all the notes which are compiled, and all of these again which I'm showing here: the shelter for hot, dry, shelter for warm, humid, and composite. I want you guys to split up your class into 4 groups. You guys can form your own groups. I think 15, 16 in a group would be still apt. Every character of the climate would be mentioned: the nature of the climate, psychological, physiological objectives, how the forming, planning, and all of these. Why don't you guys, here it's all of being listed out, but I want you guys to have a reading and you prepare your own content, because we don't need this elaborate part, as in it goes to 6 to 7 pages. We don't need so much of information. We need to concise them, how the ventilation, all of these goes through, and form a notes for this particular unit. So with this, we'll get done with the 5th unit also. And let's see, we'll have a presentation at the probably for the next class on the 5th unit, and we'll try to see what is the understanding of that. Guys, any queries on today's content? I know it's been quite, I've been rushing up now because we are short of time. If anything needs to be explained, let me know. Any queries? Guys, can I get an acknowledgement on this?
So for now, we don't have any doubts. But the thing is, we have to go through whole content again.
Yes.
Then, if you have any queries, we'll let you know.
Okay. Thanks a lot, guys. Okay, and how about who's going to take the charges in sorting out the groups?
So we already have a group list for history presentation. We can use that groups only.
How many groups are there, Satyajit?
9 groups, sir. There's already a group list in the WhatsApp group. I'll just forward it again.
You can, but we don't need so many people, right? Because only 4 topics are there, and out of which 1 topic I need to. You get me the group.
We can probably combine few of the groups. Sir.
Yeah, I'll guide the groups to get the content. That I can do that.
I just forward the thing in the group.
Okay, let me look into it. Fine.
In our WhatsApp.
Fine. Okay. Fine. You guys please have a reading all of these content again, if you can. These are all from the 3rd unit in the book. That's why it's 3.22. And have a reading of that. Once you're done with all the readings, then you can ask me on the queries. Fine. Okay, guys. Thank you for your time. Yeah. If at all you have yeah. Do you guys have anything to say? You have any queries, do let me know, and I can rephrase it and re-explain the process. Okay? Thank you, guys. Thank you for joining the meeting.
Thank you, sir.
Yeah.